Hi everyone, this is lecture 2.1, and in this lecture we're going to talk about sociological research methods. In this lecture we'll cover why we study society with science. We're going to look a little bit into the scientific method if you need a little bit of a refresher there, and then we'll quickly talk about the types of methods used in sociology. Most people think that they're actually quite knowledgeable about how society works. The fact of the matter is that most people actually have not collected their knowledge about society through science. So thus, some of that knowledge that we've accrued may be flawed. Quite frankly, every single term I teach sociology, I come across something that I learned in my childhood or maybe in my young adult life that I didn't actually apply critical thinking to, that actually turns out to not be correct, right? We pick up all of these things in our lives that a friend tells us and we trust, but the reality of the matter is it might not be true. This is why social science is super important. And the reason why scientific analysis is important also for the well-being of our society is that science is designed to produce accurate information. It is not produced to entertain us. It's not produced to win fights. It is produced in order that we have the right information that we need to make the right decisions. That's the major strength of studying society through science. Widely held beliefs that people repeat are often inaccurate and unsupported by scientific research. Here are a few examples. There's a common misunderstanding that black people use far more drugs than white people, and obviously that belief is racist. The reality of the matter is that across demographic groups, we see the same usage rates of intoxicating chemicals really across all racial groups, class groups, etc. Now, depending on where you are in the country, whether you're in an urban area or a rural area, that may change exactly what substances are used. But the reality of the matter is the number of people who seek intoxication across demographic groups are about the same. The causes of homelessness are another area where people have beliefs that may or may not be actually backed by science. Many people believe that homeless people are simply lazy or don't want to get a job. That is a common folk belief that is inaccurate. The reality of the matter is that our homelessness crisis in the United States is spurned by primarily mental health issues, in which people who are unable to maintain an actual home are not helped by the proper social services they need. And then that creates a very dangerous spiral in which an individual can become homeless. And then if a person does become homeless by some reason that isn't associated with mental health issues, they may develop mental health issues as the result of becoming homeless itself. It's a very wicked relationship. Education as an equalizer is another belief that we hold, and it's a pretty positive belief. We'd like to believe that if you get a high education, that if you work hard, no matter who you are, you can be able to compete with other people. The reality of the matter is that privilege still plays a very strong role in our society, and unfortunately, if you seek a high degree of education, you will do better. But those with high degrees of privilege, especially greater privilege than yourself, will possibly do better than you by virtue of who they were born as. This is just a quick review that we've covered in previous presentations. I want to remind us that a hypothesis is an idea about the world that can be disproved when tested against observations, and then theories are testable scientific models about how the universe works, and theories are always by definition backed up by an abundance of evidence. That's how scientists talk about theories. Every hypothesis, and to that point, every theory, has an independent variable and a dependent variable. An independent variable is the variable that causes change. It exists on its own. A dependent variable, or sometimes called DV, is a variable that is changed and is dependent on the independent variable. So to use a very practical example, if you eat too much food on Thanksgiving, you will feel sick after you eat that food, right? The independent variable there is eat too much food on Thanksgiving. The dependent variable is feel sick after you're done eating. And that's a very basic example of an independent variable versus a dependent variable. Two ideas related to independent and dependent variables are that of correlation and causation. When we have a correlation between two variables, we know there is a relationship between the variables, but we don't necessarily know the nature of that relationship. So we know that, for example, we know, for example, that I eat food and then I feel sick afterward, but we can't figure out whether me being sick maybe encourages me to eat more food. In that kind of convoluted example, that would be a correlation. But in a causation, if we know that eating the food causes me to feel sick, that is a statement of an independent variable and a dependent variable, thus being causation. If you want to remember that kind of quickly as a mnemonic device, the causation, we know what causes it. It's a common saying among scientists that correlation does not equate causation. What does that mean? That means that just because we know there is a relationship between two variables does not mean we know the nature of that relationship. We do not necessarily know the causation. Now, when we talk about these, we can talk about positive correlations or negative correlations. A positive correlation is a relationship showing that one variable rises or falls when the other variable does as well. An example of this would be obesity rates as poverty rates increase. So we see in the United States, both via correlation and causation, but I'm just going to use this as a positive example, that as people rates of poverty go up, obesity rates go up, right? They are both going in the same direction, thus being a positive correlation. In terms of a negative correlation, that is when one variable increases, the other variable decreases. So as marriage rates decrease, male unemployment rates increase. I could go into great detail explaining those hypotheses, but what the main point there is that positive phenomena go in increase at the same time, while negative phenomena, one increases as the other decreases. Most sociologists believe that they should not allow their personal beliefs to influence their research. The term used for this was originally used by Max Weber, and that is called value-free sociology. And he stated that researchers should identify facts without allowing their own personal beliefs or biases to interfere. We need to, as sociologists then, if we're studying something that we care deeply about, let's say racial inequality, if we're studying that thing, we need to look at our data and our objectives in a scientific way when we're analyzing the thing. I had a professor in grad school that said, what you need to do is take your morals and values and go put them on the shelf while you're doing that. And then as a scientist, analyze the data. And then when you're done analyzing the data, you can go get your morals and values and take them off the shelf again and use that data in a way that you feel benefits the cause. But so that in that way, when you're doing the analysis itself, that does not get in the way of the analysis. Now, this is sometimes compared to Marx's concept of praxis. Marx stated that the role of an academic is to use their academic knowledge in order to create positive social change in the world. And this can coexist with the idea of value-free sociology. So as a value-free sociologist, when I'm analyzing my data, I'm doing it with my scientific brain, and then when I'm done analyzing that data, after I've produced that data, I can then take that data and give it to organizations that can use it for the betterment of the world. That is that of praxis. Now we're going to talk a little bit more about the scientific method itself. You may be most familiar with the scientific method, maybe in a high school natural science class. I got a lot of it in my physics class, and I also got some of it in a chemistry class. You may have had a similar relationship with this. The scientific method is a procedure for acquiring knowledge that emphasizes collecting data through observation. As I stated in previous lectures, this is what makes something science. If an academic uses the scientific method, then they are engaging in science. This is what makes science. Here is one way to present the steps of the scientific method. First, we do a literature review. So what we do is we check out all of the knowledge that is known about this thing at the time. Then we develop our hypothesis. We put together what it is that we predict will actually happen about the thing we want to study. Then we determine our variables. What in our statement is the independent variable? What is the dependent variable? Then we determine our operational definitions. What exactly do I mean by that variable? What exactly do I mean by another variable? If I'm talking about obesity rates, what do I mean by obesity? Am I talking about someone who's 20 pounds overweight? Am I talking about someone who's 200 pounds overweight? We need to be very exacting in this phase of operational definitions. That phase can actually take a while and takes a great amount of effort. Then, once we have figured out what exactly we mean by our hypothesis and our variables, we collect our data. So we go and we use whatever research method we actually are going to use. I want to point out the scientific method is not in and of itself a research method. It's a confusing thing. We're going to talk about actual scientific methods that are used in the data collection phase in a few minutes. Then we interpret our results. We see what is all of the information that we got in our research methods, and we analyze the situation and we figure out what the heck that thing means. And then finally, we repeat any of those phases that may be needed. Maybe we find when we're interpreting our results that we didn't get all of the information we need, and then we might have to double back on some phase and redo that and redo part of our research until it's good enough. This is a slightly different way of imagining the scientific method. I'm not going to work through each phase, but what I want to point out here is the reality that most scientists are very well aware of, that the scientific method doesn't always go in a linear phase. That actually you can start on really almost any spot in the scientific method and still be doing being fully a scientist. The key is that you do every single one of those phases and you do it accurately and as makes sense for the individual project. It doesn't have to be a purely first you do this, then you do this. It can have more of a flow to it. The scientific method helps us determine correlation and causation. I'm sorry, this is a little bit repetitive. And we talked about that a moment ago. But the reason why we use the scientific method is because it helps prevent flaws in research. It is quite easy when you're doing scientific research to fall into a number of traps that may cause your analysis to be inaccurate. One such example of that is the spurious correlation. It's when it appears that there's a correlation between two variables, but the reality of the matter is that it's being caused by some third party or intervening variable. This most common example is given, which is sometimes known as the ice cream murder hypothesis. You will observe, or you could observe if you looked at the data, that over the course of a given year, that as ice cream consumption rates go up, murder rates go up. This could lead you to believe that as people eat more ice cream, they are somehow driven to kill, right? Which obviously is nonsense. The reality of the matter is that as summer goes on, then people eat more ice cream. And by virtue of more people being exposed to more other individuals, then murder rates go up. That's a basic tenet of criminology. The more people you interact with, the greater chance very, very small chance that you could potentially be murdered. That's the third variable there, is the number of people you're interacting with. It doesn't have to do with the ice cream itself. Part of the research process is to identify your target population and to select an appropriate sample. A target population is the type of person you want to study. So examples of this could be single African American mothers who live in Cincinnati, Ohio. That would be a target population. In all likelihood, your target population is likely to be much too large to study completely. There is no way you could interview all of the single African American mothers who live in Cincinnati, Ohio. There are definitely thousands, maybe tens of thousands of them. So, from your target population, you choose a sample. The sample are the specific people that you actually study, and you want that sample to be representative of your target population as a whole. So an example of your sample to go with your target population here would be 500 African American mothers who live in Cincinnati who has volunteered to actually do your study. Now we're going to briefly talk about a few types of methods. Methods can be broken down into two broad categories: quantitative methods and qualitative methods. Sometimes there's a third category put in called mixed methods. That simply means some combination of quantitative and qualitative methods. There are different ways to actually collect information about a topic, and we have those categories there. Quantitative methods translate the social world into numbers that we can study mathematically. Quantitative, numbers. That, I guess, quantity, numbers. Think of it that way. And then qualitative methods are all of those other things that we can't study using numbers and statistics. It could be an image. It could be an interview with an old person that went through some sort of collective societal trauma. It could be any number of issues. Now, a quite large degree of how we study our society can absolutely be put into statistics, but also a large amount of our social life and social world cannot be put into statistics. We need both of these in a proper study of society. So here is a list of some of the methods in sociology. We have some quantitative methods being surveys. Experiments are often quantitative, and statistical analysis is often quantitative. All of those typically take the information that you get via that research method and then turn it into numbers. Some examples of more qualitative methods could be ethnography, also known sometimes as participant observation. To be very clear, participant observation is a type of ethnography. Not all ethnography is participant observation. And what that thing is going into the field where people live their lives and observe what is happening there. That's what ethnography is, and it's a very, very qualitative research method. Content analysis is another research method that you can use to analyze texts or works that have been done. So you can analyze 5,000 photographs and find trends in those photographs. And that, in doing that, you are analyzing the quality of the photographs in an effort to really figure out a given social phenomena. And then also interviews with individuals, where instead of a survey where you're asking them to fill out a form and choose certain answers associated with certain numbers, in interviews, you're sitting down with the individual and you're trying to figure out what is happening in this social phenomena as related to the individual. Again, a very, very qualitative research methods. Okay, that is it for right now in terms of this presentation. As with everything, if you have any questions, please let me know and I will do my best to answer your questions as they come up. Thanks so much.